Hi friends, let us see the fundamentals of electrical engineering. First, let us discuss what is charge. You might have studied in your earlier class what is atomic structure. So this is the atomic structure of an atom. When I consider a particular atom consists of nucleus in which we have protons and neutrons. Hope you are able to see. This red color one, we call it as protons, and this yellow ones are neutrons. They are present inside the nucleus. Okay, and the protons are positive charge, whereas electrons will be revolving around the nucleus in a specific orbit. And this first orbit is called K shell, and the second orbit or shell is, we call it as L shell. And electron is negative charge. Electron is having negative charge. So the next concept, let us see what is meant by electric current. Electric current is defined as rate of flow of charges. Okay, so it can be written mathematically as I is equal to d by dt of q, or I is equal to q by t, where q is charge, I is current, and t is time. So current can be defined as rate of flow of electrons, and the SI unit of current is coulomb per second. Since we know that the SI unit of charge is coulomb and the SI unit of time is in seconds. The scientist who has given this unit, okay, so who has found the concept of current, okay, it is named after the scientist as Ampere, Andre Marie Ampere. So who just found the presence of this current, it is named after the scientist, so it is given the SI unit Ampere. The smaller units of current is milli, that is 1 milliamps is equal to 10 to the power minus 3 amps. Micro is 10 to the power minus 6 amps. Okay, and the larger units of current will be kiloamps, which is, suppose if I write 1 kiloamps, so 1 kiloamps is equal to 10 to the power 3, 10 to the power 3 amps. Okay, fine, 10 to the power 3 amps. Fine. So can you see the direction of the current and the electron flow? So in this circuit you can find the direction of the current is from the positive terminal of a battery. See, this is the direction of the current, which is given with red arrow. And just observe the direction of, excuse me, let us observe the direction of the electrons. Just see, it is opposite to the direction of the current. Why? The direction of the electrons is, it is from the lower potential to higher potential. Okay, whereas the direction of the current is from higher potential to lower potential. Fine. So we know very well that always the water flows from the higher potential to lower potential. That is called water current. The same way, the scientist, that is before the discovery of electrons, they thought that the current flow will be from higher term, that is higher potential to lower potential, and they had taken the direction in that way. But actually, after the invention of electrons, they found that the current is due to the presence of electrons. Before the discovery of the electrons, they had in their mind the conventional direction of the current would be from positive terminal to negative terminal. That is, they considered as positive charges, flow of positive charges. Okay, so the direction of the current is opposite to the direction of electron flow. So this is kept as such for the analysis. They did not change this concept. So now let us move on to the next. You know what all these are? These are ammeters. So you can find here ammeters. Okay, so here you can find milliamps. Okay, what is that? Below A they have given a line, which means that is the DC ammeter. It is used to measure DC current. And you can see this is microampere, this is milliampere. So it is used to measure smaller currents. These two are used to measure smaller currents. Milli is a smaller unit, and further very small unit is going to be microamps. Okay, so the instrument used to measure the current, we call it as ammeter. Okay, the instrument used to measure the current is called ammeter, and we represent the symbol of ammeter by A within circle. If we put a line, it is DC ammeter. Suppose if we represent it like this, it is a AC ammeter, which is used to measure AC current. So we'll be discussing what is this AC and DC currents. Fine. And now we are going to see potential difference. What is meant by potential difference? The difference in potential of 2 points. This is A, this is B. So there is this point A has one potential and B has some other potential. So the difference in their potentials, we call it as potential difference, and it is also given another name, electric potential. Electric potential means it is the work done in moving the charge from one point to another. Say for example, the charge is from A point. So we are moving the charge from B to A or A to B. Okay, so work done in moving the charge from one point to another, we call it as electric potential. Okay, and the other similar terms related to this potential difference are voltage and electromotive force. All these have the same unit, volts. Okay, as I told you, see here, voltage, that is electric potential, is equal to work done by charge. What is the unit of work done? Joule. What is the unit of charge? Coulomb. Joule per coulomb. So joule per coulomb is an equivalent of 1 volt. Okay, so what is this 1 volt? See, suppose 1 joule of work is done in moving 1 coulomb of charge from one point to another, then we say that potential difference of 1 volt is applied. Okay, fine. Actually, it is named after the scientist. The unit is given after the name of the scientist. Fine. So now the smaller units are, as I have discussed in current. The same way here we have smaller units for voltage and larger units for voltage. Okay, so millivolts and kilovolts will be the larger units. Smaller units will be millivolts or microvolts. Fine. Usually microvolts we will not have of that range. It will not be used for any purpose. It's of no use. So we'll go for only millivolts and volts. We can find this voltage, okay, that has been developed in diodes and some other electronic devices. Fine. So now we will move on to the instrument voltmeter. What is the instrument used to measure potential difference or voltage? We call it as voltmeter. Okay, here we have millivolt having a range 500. Okay, 0 to 500 range, millivolt. And here we have another voltmeter, and these two voltmeters are used to measure DC current. That's why you can see here moving coil is DC. Okay, it's a DC voltmeter. It's used to measure DC voltage. So let me explain to you how do we get DC voltage. So these are the devices which produces DC voltages. What are they? Cell. You may be knowing what is cell. We'll be using cell in battery, that is, what is it, in toys, remote, okay, and in wall clock. So these are cell, okay. Group of cells, we call it as battery, okay. Cell will be having either 9 volt or 5 volt, okay, or 12 volt, depending upon the capacity of the equipment. And battery eliminator. So I will show you all these things one by one and I will explain to you. This is cell. I think you are familiar with cell. This is the positive terminal. This is the positive terminal and this is the negative terminal. Okay. And this is battery, group of cells, as I already discussed. So here we have two terminals, positive terminal and negative terminal. Okay. So this is a bigger range battery which will be used in car. Okay, fine. So next here, this is battery eliminator. So you can find that this battery eliminator will be having a cord wherein you can plug it to the supply. Okay, and here we have on and off switch, and you can see the variation of the voltage. How much of a voltage you want to give, from 2 to 12 volt you can select and give. And this is fuse. Okay, so this is positive terminal and this is negative terminal. Fine. So when the switch is on, you will get the indication here, red light. Fine. So this is battery eliminator. It is used to give the different voltages. And here is DC generator. What is this DC generator? DC generator is another device which produces DC voltage of higher range. Okay, fine. So now we will discuss what is meant by Ohm's law. I think you are familiar with what is Ohm's law. At a constant temperature, the current flowing through the conductor is directly proportional to the voltage applied. Say, for example, I'll draw here. So we have a conductor here and we apply the voltage. And here, how much of here, this is the battery. Okay, so from here, positive terminal, the current flows. So how much current will be flowing, that is dependent on here how much current will be flowing, okay, through the circuit, that is dependent on the voltage. So I is proportional to V, or else we can write V is proportional to I. Okay, in order to remove this proportionality sign, we introduce a constant. That constant is resistance R. Okay, so V is equal to R into I. So this R is called a constant. According to physics, we know that in order to remove the proportionality sign, we have to introduce a constant, and that constant here is resistance. Okay, so from the Ohm's law, we have got the relation that V is equal to I into R. How to remember this? Ohm's law. Okay, you know, Pujari or Iyer. Okay, Iyer. V is equal to Iyer. You remember that way. Om. So the person who chants Om in the temple, Iyer. So V is equal to Iyer according to Ohm's law. So you can write, see, this is a magic triangle. Can you see division symbol here? So V by I is going to be R. Okay, and here also we have a division symbol here. So I can write I is equal to V by R. Okay, R is equal to V by I, or V is equal to I into R. So we have a multiplication symbol here. So V will be equal to I into R. Hope you can understand. See, V is equal to I into R. Okay, and then R is equal to V by I. Okay, then I is equal to V by R. Fine. So we can rearrange and get the formula for the different quantities from this. Okay, this is magic triangle. So now we are going to see circuit to verify Ohm's law. How to verify Ohm's law? See, this is the model. Okay, so this is the model in which we will be you can see here very clearly how the connection is given. So this is the plug where you will connect, and we have a battery eliminator to which we have connected one-way switch. Okay, it is a switch, and to the other terminal we have connected to Rios Chat. You may be wondering, see the same, you have to see to this circuit diagram, and accordingly we are going to connect this assembly. So how it is done? See, this is battery. So here is, where is battery? Here is the battery eliminator, and we have a plug key. So this is the plug key, and we have a Rios Chat here. So we have a Rios Chat. So one end is connected to the plug key, other end is connected to this voltmeter, other end is connected to voltmeter, or you can say this resistor. So resistor and voltmeter, they are connected in parallel. Okay, so see here, positive and negative terminal, it's connected across positive and negative terminal across the resistor, and it is further connected to ammeter. See here, it has been connected to ammeter, negative terminal of ammeter. This is negative terminal of ammeter. Positive terminal is connected to battery. Positive terminal is connected to positive of a battery, positive terminal of a battery. So this is how we will be connecting, and this circuit is to verify Ohm's law. So what we are verifying? By increasing the voltage. Okay, so here what is the purpose of this Rios Chat? So you may be thinking, what is this Rios Chat? It is a resistance, actually it is a resistance, and it's a variable resistance. We can vary the resistance from 0 to whatever the value is. Okay, so whatever the value is, that range, according to that range it will be, we can vary it. Okay, so according to Ohm's law, you know that V is equal to I into R, right? And now R is equal to V by I. Fine. So by increasing the resistance, what happens? By increasing the resistance, voltage will increase, but the current will decrease. Okay, because they are inversely proportional. And further, I can once again write here and explain to you, R is equal to V by I. So now you find that as the resistance is increasing, what happens? The current is decreasing. And suppose if okay, so now suppose if the resistance is decreasing, current will increase. Okay, so using this concept we have taken the variable resistance. So initially the resistance will be given maximum, okay, 0, and then we will keep on increasing the resistance. So if we keep on increasing the resistance, what happens, ma? If we keep on increasing the resistance, okay, current will decrease. Fine. So that we will verify. So what we will do, by varying this resistance, we will tabulate what is the value of V and what is the value of current, and then we will find out what is the value of R. So we will divide V by R to get V by I to get R. Okay, and we will check that for all the values of V and I, we find that the R value is going to be constant. Okay, that is how we verify Ohm's law. Fine. So we will see here, this is called plug key. Can you see plug key? So this is the open condition of plug key, and whereas this is the plug key which is closed. This is a closed condition. Only if this is closed, the current will be flowing, and if this is in open condition, no current flows. No current. Fine. Okay. And this is Rios Chat. So what is Rios Chat? It is used to vary the resistance. It is used to control the current, as I have already discussed. R is equal to V by I. So we are going to control the current. So by increasing the resistance, we are decreasing the current. Current is reduced. By decreasing the resistance, current is increased. So there is a control over the current. Okay, according to this relation. And we know that I is inversely proportional to resistance. So this already we have discussed. This is the setup of Rios Chat. This is called Rios Chat. Fine. So this is how we will be connecting. This is another circuit, I'll tell you. See, this is the battery eliminator, so we can change the different voltages. Okay, instead of using Rios Chat, so here no need of using Rios Chat. We will be taking only the selector, voltage selectors. Okay, only battery eliminator will use and keep on increasing the voltage, and we will find what is the current flowing through this resistor. Okay, and we will find what is the voltage across this resistor.